Now let us look at the solution procedure for transportation planning, and we will take an example for it and we will clarify the concept with the help of this example. Let us consider a transportation route with 5 cities and 3 modes of transportation. The 3 modes of transportation are rail, road and air. Between any 2 cities, we can use any of these 3 modes. The transportation cost for the various city pairs are given in the table. So if for city pair 1 and 2, the mode rail will have a cost of 3, let's say. For a city pair 2 and 3, the rail has a cost 4, and so on. And in the similar fashion, we have the cost for transportation cost for road and air as well. Now, the intermodal transfer costs are, so if we are transferring, there is an intermodal transfer from rail to either road or air, or it remains on rail, the transfer costs are given. Of course, if the mode of transportation doesn't change, then the transfer cost would be 0. But if the mode changes from rail to road, it will incur a cost of 2. From rail to air, it will incur a cost of 1. And similarly, from road to switching to other modes will cost different costs, which are given in the table. So the shipment size Q is assumed to be 20 units. Determine the optimal model combination. The above example is solved by using the dynamic programming. We talked about some of the concepts of dynamic programming in our previous sessions. So I will not go through all the calculations. Instead of it, I will go through some of the sample calculations. But you must keep it in mind that dynamic programming is actually based on backward induction. So the problem is actually solved from the last stage. And you also need to define different states and decision variables in dynamic programming. So for understanding this problem, I would suggest that you should go through the procedure of dynamic programming, or refresh yourself for the concepts of dynamic programming. So as dynamic programming is based on the backward induction, so we will start from city 4, which is the last city, with rail as the incoming mode. If it happens, then P4, rail to air, that means the mode of transportation changes from rail to air, are T4 rail air plus Q the shipment size, C the cost from switching to air for a pair of city 4 and 5. You should know how to develop this recursive equation. And of course, the cost would be 1 plus total quantity, which is 20, and the transfer cost. The cost of transportation. The transfer cost is the first part, that is T4 rail air. So the cost comes out to be 81. Similarly, if we are using rail as a mode of transportation for the last city and you switch to truck, you will compute it in the similar fashion. And if you are using rail, the other option would be rail. So you can see that these recursive equations are actually, functions are actually using all the modes of transportation. So if there is no switching, the cost is 120. That means the mode remains as rail. Hence, With rail as the incoming mode at city 4, the best outgoing mode is air. Why? Because from rail to air, if you can see, the cost is the minimum, which is 81. Similar calculations for other incoming modes lead to the best outgoing modes. What you need to do? You need to calculate P4 again. When this is just a sample calculation, when rail is used as a mode of transportation, you have to use then air. For example, P4 air rail, P4 air truck, P4 air. Similarly, for truck, you will do the same thing. That would be truck air, P4 truck rail, P4 truck. And then you will select the best outgoing mode, which will be actually the minimum of them. Then you will calculate it for city 3. So from city 4 you will move backward to city 3. I have given these sample calculations for city 3 as well. Of course, it would be based on the recursive function, which is to be used in backward induction games like dynamic programming. So P3, for example, I'm taking the same rail, the rail air. That would be the transfer from rail to air cost, T3 rail air plus QC34 from the city pair 3 to 4 of air, plus the previous cost P4, which is coming from city 4 solution of air. That is actually the backward induction concept, that you have to take the solution from the previous, from the last city, the city which you have solved, or the stage you have solved. The cost comes out to be 201. In a similar fashion, you will look at rail truck and rail. You will calculate it for city 2 as well as for city 1. And you have to calculate, it would be a long calculations because you have to enumerate it. आपको हर mode of transportation के लिए ये solve करना पड़ेगा और फिर उसमें से minimum देखना पड़ेगा. ये तो सिर्फ example calculations है. So it would be a long and lengthy process if you are doing it by hand. Of course, we have a luxury of off-the-shelf softwares. So dynamic program, this type of simple dynamic program can be solved through a software as well. So at the last stage, which would be city 1, we will have the similar type of recursive function. But of course, this would be the last stage in our game. Then there will be no transfer cost involved in it. So that is why T is not there for your sample calculation of P1. Of course, there will be a calculation for P2 as well. I have just shown you the sample calculations. The overall solution is given in the table below. That is, these are the minimum costs involved. So for city 4, by rail to air, you switch from rail to air, the total cost is 81. If you switch from air to air, the total cost is 80. If you switch from truck to air, the cost is 81. Similar case, city 3 and city 2 costs are given. So the best city pair would be, for pair 1, 2 would be truck, 2, 3 would be air, 3, 4 would be rail, and 4, 5 it would be air. Why? Based on the minimum cost. You have to look at the mode which actually gives you the switching of the modes, which actually gives you the minimum cost. So students, by using dynamic programming, we have seen the solution procedure, optimal solution of course, for some transportation planning, in which you have to transfer from one mode to another, or whether you should not transfer from that mode to the other mode. Thank you.